All right, I'm bringing up my KSP chart just so I can get my KSPs for these different ones before I get going on it. So that's this one. And I need to find... And if you're not sure, again, remember, like, things that have, like, Na in it, that's not going to be very... I mean, that's super soluble. Like, anything with a strong acid in it, not strong acid, but a alkali metal in it is going to be very soluble. Anything with a nitrate in it's going to be soluble. Anything with, like, this is a strong base, so that's going to be super soluble. So the KSPs that I need, I'm going to need this one's KSP. So BA, that's going to be at the top. BA, there it is. That one's KSP is 2.3 times 10 to the minus 8th. Now I need to find leads. That'll be with the L. Oh, wait, actually, okay, lead and iron. So here's iron, Fe. I need FeOH3. So that's this one. So that one is 4 times 10 to the minus 38th. And then the lead one, or sorry, lead is right below it, is 4 times 10 to the minus 8th. All right, that's the first step, is you got to get the KSPs of the things that you're pretty sure are the insoluble salts. Now we're going to figure out where are the common ions. So when I look at these two, oops, that is too big. Let me get that a bit smaller. So the SO4 part on this one is what's in common with the SO4 part on that one. The PB is what's in common on those two. And then the OH is what's in common in those ones. So that's the next step. And then the final step is to figure out how much of the common ion I have. Then I'll fill in the ice chart. So if I have 0.3 molarity, that's the same thing as moles in 1 liter, of Na2SO4. If I want to know what is the molarity of the common ion, which is the SO4 part, Na2SO4 into moles of SO4. Notice that it was a 1-to-1 ratio. Like, there's an understood 1 there. There's not like a parentheses with another number. So there's just one of those and one of those. So that molarity of the SO4 is still 0.3. That's the molarity of that one. Now I'm going to jump over here and figure out the molarity of this one. So 0.50, and you get so that you don't have to write this out like this every time. NO3, 2, and that's in 1 liter because it's molarity. And in 1 mole of PB NO3, 2, I just have 1 of the lead. So that one's also the same, so that one's good. So that's 0.050 molarity of just the lead. And then finally for this one, my OHs, so I have 0.20 moles of BaOH2 in 1 liter. And so in 1 mole of BaOH2, I have how many moles of OH? 2. So this one is not the same. So this one is 0.40 molarity of OH minus. All right, now I can solve. Each of these are separate problems, but sometimes it's easier when you're thinking about things to kind of work them all out, certain steps of them all at the same time. All right, so I'm going to work out for salt 1. So BaSO4 is what I am writing the equilibrium for. That turns into Ba plus 2 and SO4, 2 minus. This part doesn't ever matter because it's a solid. These part do. They do. But instead of it being 0, I now have some SO4. This one is still 0, but I have some of that one. Minus x, minus x. So that's plus x. Whew. So this is 0.30 plus x. Note that I'm going to assume that x is way smaller than 30 so that I can just put in 0.30. So KSP is equal to the barium times the SO4. So that becomes X times 0.30. And so the KSP I figured out, I looked it up, was 2.3 times 10 to the minus 8th. So I just had to divide both sides by 0.3. So 2.3 e to the negative 8th divided by 0.3 gives me 7.67 times 10 to the minus 8th. So that is my molarity, my molar solubility. And maybe you'd have had to change it into grams. Maybe you wouldn't have had. But that's the first one. All right, now I'm going to do the second one. So 2 is PbF2. It becomes Pb2 plus 2F minus. This part doesn't matter because it's a solid. The thing I had in common was the Pb right there, 0.050. I don't have any of that one. Minus x, plus x plus 2x. 0.050 plus x, but I'm going to assume that x is way, way too small to matter. So I'm just going to put in 0.050. And then this is 2x. The KSP is equal to PB, 2 plus, times f squared, 0.50, 2x squared, and I looked this one up, and this one is 4 times 10 to the minus 8th. And so I'm going to say 4 times 10 to the minus 8th equals 0.50 times 4x squared. So I need to divide both sides by 0.5 and 4. 0.5 and 4. And that way I'll get x squared is equal to 4 times 10 to the minus 8th over 0.5 times 4. And then I'll just take the square root of both sides and I'll have the answer. So 4e to the minus 8th divided by 0.5 divided by 4. And then the square root of the answer gives me 1.41 times 10 to the minus 4. And then I'm going to do the last one.